Okay. This is part 2 of lecture 8. Is just a small section of VSEPR, and that is VSEPR with multi-centered molecules. More than one common center. So I don't have an official slide for this, but I am going to show you the slide here of the most commonly used electron group arrangement. So there's your electron group number. This is when you add the X's and the E's together. It's the number of connections, the number of electron pairs around your center atom. If you only have 2, that's linear. And for linear, it has to be two X's, AX2. That's the only option you have. For electron group number 3, you have 3 connections or electron pairs around a central atom. And if they are all 3 bonded with another atom, it's an AX3 trigonal planar. But if one of them is an E, is an electron pair, then you have the V-shaped. Same for the tetras. Electron group number 4, the electron group arrangement is tetrahedral. There are 4 electron pairs around it in some form. If they're all bonded to atoms, it's AX4, tetrahedral shape. If one of the electron pair units is an unshared pair, you have your 3 bonded atoms form a trigonal pyramidal connection, and that's an AX3E. There's your E. If you have 2 E's, AX2, E2, these 2 electron groups, electron pairs, are going to push your bonded atoms a little bit, and so it's bent or V-shaped. So what you do is you calculate each of these for the individual atom that has electron groups around it. So I'm going to work some examples from the Lab 5 exercise. Okay. So I'm going to start with the simplest. And that's C2H6. So this is going to have 2 centers, 2 carbons. We have to do the Lewis first. So how many valence electrons do we have? We have 2 carbons at 4 electrons each, 4 valence electrons, plus 6 hydrogens at 1 valence electron each. So this is 8, this is 6, and we have 14 valence electrons. I'm not going to do the Mortimer method because I know this is all just single bonds, very straightforward bonding. So the Lewis structure, we have 2 carbons. These are the center atoms, so put them next to each other. Put the hydrogens around. There are 6, so there's going to be 1, 2, 3 on each carbon. Okay, double check. Do I have all of my atoms? I have 2 carbons. I have 6 hydrogens. Do I have an octet rule satisfied for each of them? I have 4 bonds around carbon. That's 8 electrons. So yes, and yes for this carbon. And have I accounted for all of my 14 valence electrons? Up here. So we have 2, 4, 6, 8, 10, 12, 14. Yes. So this is the shape. This is the Lewis structure that we're now going to do the molecular shape of. So I'm going to erase this and move it up so I have room. So the Lewis structure is 2 carbon centers and 6 hydrogens. You have to do the AXE, and you have to do them individually. So this is carbon 1, and that's carbon 2. So we're going to do carbon 1 first. A is just for the carbon, represents X is how many connections it has. It has 1, 2, 3, 4 atoms connected to it. It has no E, has no dots. C2, A is for my carbon. X is for the number of atoms connected to it. We have 1, 2, 3, 4. There is no E. So they're the same. Your electron group number is 4 for each. That is the tetrahedral. Electron group arrangement. Let's go back to that slide a minute. So here is the electron group number 4, is tetrahedral. That's the electron group arrangement. Because I have no unshared electrons, unshared pairs to push any of these around, the shape is also going to be tetrahedral. So both carbons are going to have this shape. So how do we draw them? Okay. One of the things in organic chemistry that we do, you can't do this now, but we do so many larger molecules, is for a carbon-hydrogen chain, we'll actually draw this. And this is carbon, 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 carbon. So you can use, this is a tetrahedral. For tetrahedral structure, you can use this as a starting point. Now I have 2 carbons, so I'm going to, and if you draw too many, just erase one. So I'm going to use this as my carbon, that's my carbon. I'm going to use this for my hydrogen, and this for my hydrogen, because it works. So that's carbon 1 and that's carbon 2. So let's start with carbon 1. Carbon 1 has 3 hydrogens around it. It's tetrahedral. So here are your first 2. You're in plane. You're coming at you. Your wedge, roughly a third away, a third of the space. And then the hydrogen going behind the board is with the straight lines. Not dashed lines towards the hydrogen, but hashtag lines, hash marks, okay? So that's my first carbon, carbon 2. If this is down, make this up. And I'll show you what I mean again with another illustration. But my hydrogens going out in front of and behind the board are down, so put these up and do it like rabbit ears. So, right? And there's your structure. So you do each individual carbon, each individual atom separately. Now let me show you what I mean about these little hydrogens. When we, in organic, we do this, if you put your carbons in here, these hydrogens will point down. They're going to be at opposite ends. These will point up. You always point them in the opposite direction of your angle. That's the convention. So that will help you when you're doing the tetrahedral multi-centered atoms. Put your hydrogens in the opposite direction. It helps you orient them. All right, so another example. What about 3 carbons? So C3H8. Again, you have to start with Lewis. Valence electrons, we have 3 times 4 for carbon, plus 8 times 1 for hydrogen. So this is 12 and 8, that's 20 valence electrons. I know this is a very straightforward carbon chain, so I don't need to do Mortimer because I know these structures. So the Lewis would be carbon, 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 hydrogens on each carbon. Right? Do I have all of my atoms? I have 3 carbons, 3, 4, 5, 6, 7, 8 hydrogens, and each carbon satisfies the octet rule. It has, each carbon has 4 bonds, so that's 8 electrons. count my valence electrons, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So yes, I had 20. So there is my Lewis structure. Again, I'm going to move it up. Oh, I moved it too far up, didn't I? So I'm going to do my ziggy-zaggy. If you do too many, just erase them. I'm going to make this a hydrogen. I know by looking at these, just because I've done these enough, that each of these is tetrahedral. But if you work out the AXE, and you're going to find that each AXE, X is how many atoms it's connected to, is going to be AX4. 1, 2, 3, 4. This carbon is connected to 2 hydrogens and 2 carbons, so that's 4. This carbon is connected to 3 hydrogens and 1 carbon, so that's 4. So all of my carbons are AX4, which is tetrahedral. So because of that, I can use this. See, I drew too many, so let's erase it. So this is going to be carbon 1, carbon 2, carbon 3. And now I'm just going to use that rabbit ear rule, roughly a third away, put my wedge, and then behind it put the hydrogen. That's the hydrogen going behind the board. This is coming out at you. These are down, so put this one up. This is up, so put these down. It doesn't matter which one you put going forward. That's it. Those are dashes, by the way. Which one's forward, which one's back, really? Let me make that better. Okay, so I have my 3 carbons. They're tetra. That's a little long. Make that a little bit shorter. And that's my molecule. But what about if we don't have all tetra? So let's see. What about this one? This one is also all tetra, but I'm just going to draw the structure. Okay, I can already tell you that my carbons are all AX3, 4, excuse me, sorry, AX4, because I've done this a lot. So, but you can work this out. 4 atoms connected to it, X4. This carbon has 4 atoms. It has 2 hydrogens, a carbon, and an oxygen, X4. This carbon has 3 hydrogens and an oxygen. So all of my carbons have an AX4 configuration. That's tetrahedral. The molecular shape will be tetrahedral. There are no E's. But my oxygen is A. My X is 2 carbons. But it has 2 electron pairs, 2 sets of dots. So that's an E2. The electron group number is 4. 2 plus 2 equals 4. So this is still the tetrahedral electron group arrangement. That's your starting point. But the shape is bent. So go back and look at the slide or your notes. AX2E2 is bent. The 2 E's are going to push the AX combinations, the bonds, down a little bit. Now, because I do have a tetrahedral, they're all the tetrahedral electron group arrangement, I can still do my jiggy lines. And I don't know how many I'm doing. I'll erase what I don't need. Because they are still tetrahedral electron group arrangement, so the basic shape is that, the spacing. That's carbon, carbon, an oxygen, a carbon. So I didn't have too many. And a hydrogen. And a hydrogen. Okay, so this hydrogen comes off this carbon. Put on my wedge, my dash. These are down, so this has 2. Put them up. This oxygen doesn't have any hydrogens. It's a bent configuration, but the bent configuration is these atoms. That's my A, my XX. So that's my bent. You're used to us using water as an example, OH2. If these were H's, that would be the same shape as water. So that's my bent part for oxygen. And then we're at the up. So again, wedge. Okay, and so there's my configuration. There's my shape, my VSEPR. And you have tetrahedral, tetrahedral, bent, tetrahedral. So when you're giving me the names, you don't have to give me every single one. If you go left to right, you can just say tetrahedral times 2, bent, tetrahedral, because you have to give me the names where it says molecular geometry in the worksheet. So you can just read it left to right. I'll understand what you're saying. Let's do one where we don't have. Okay. So again, I'm just going to draw the structure. So CH, H, H. Okay. So we have carbon 1, carbon 2, and oxygen. This oxygen does not have a second connected atom to it. You have to have at least 2 atoms connected to have us to be a center. This doesn't. It has 1 connection. So it doesn't, we don't do an AXE for that. The carbon 1 is A, 1, 2, 3, 4 connections, X4, no E. Carbon 2 is A, 1, 2, 3 connections, no E. Oxygen is A, it's always A, 1, 2 connections, the hydrogen and the carbon, 2 electron pairs, 2 sets of dots, E2. All right, so we have something different here. This electron group number, this is 4, but this is only 3, and this is 4, 2 plus 2 equals 4. So therefore, the electron group arrangement, let's go back and look at the slide. The electron group arrangement for 4 is tetrahedral. Why does it do that? Sorry. For 4, of course, it's tetrahedral, but for 3, electron group number is 3. That is trigonal planar. That is the electron group arrangement. Because I have no E's, there's nothing pushing it out of shape. The shape is also trigonal planar. Okay, so that's your second carbon. So I'm going to start with my first carbon. I don't have all tetrahedral, so I'm not going to do the line. This carbon, you always keep your atoms, the skeleton atoms, the backbone atoms, in the plane of the paper. So my other carbon is going to come up here. My hydrogens will come out and behind. So this one is going to be the same. Roughly a third, and then slightly behind it, the other hydrogen. This carbon, each of these is basically 1/3 of a circle. So mentally divide that into 3. Okay. Very, very important. Write down your multiple bonds. They are a critical part of the structure and the chemistry of a molecule. So if you have double bonds, you put double bonds. If you have triple, you put triple. It's very important. It's not the same structure if you don't put your multiple bonds. So put both bonds. You do not have to put your unshared pairs, but these bonds affect the chemistry and the structure of a molecule. So now we have an oxygen, and this is bent. You can bend it up, you can bend it down, it doesn't matter. So your shape is tetrahedral. And again, you can just write it for me, left to right. Trigonal pyramidal and bent or V-shaped. Okay, do you see that? So that's your structure there. So this is how you do a multi-centered molecule, is you take each atom separately, you calculate the electron group number for each one individually, and then you apply that when you draw each section of the molecule. But they are still connected. It's just showing what the angles are, and some of them are going to get kind of twisty and weird. Just do the best you can with this. Okay, so that's all of this section. There are some good videos. You can go online. You can Google VSEPR with multi-centered molecules, and there are other YouTube videos that might help you, but mostly you just have to work through it. Okay, so that is the end of lecture 8.